that's how it starts. We go back to your house.
For number 2, we have y double prime minus 2y prime plus y equals e to the t. So we have the homogeneous equation yh double prime minus 2yh prime plus yh equals 0. That is a characteristic equation lambda squared minus 2 lambda plus 1 equals 0, which gives us lambda minus 2 squared equals 0, which gives us the repeated root of lambda equals 1. So that gives us a y1 of e to the t, and our y2 has t e to the t. We can find y1 prime, which is e to the t, and y2 prime, which is t plus 1 e to the t using product rule. Now we can go ahead and solve the system v1 prime y1 plus v2 prime y2 equals 0, and v1 prime y1 prime plus v2 prime y2 prime equals the forcing term, which is e to the t. We can plug this in, giving us e to the t v1 prime plus t e to the t v2 prime equals 0, and e to the t v1 prime plus t plus 1 e to the t v2 prime equals e to the t. You can write this as a augmented matrix e to the t e to the t 0, e to the t plus 1 e to the t, and e to the t. So now to solve this, we can divide or multiply r1 by e to the negative t. That gives us 1 t 0 across the top. And then r2 is going to be also multiplied by e to the negative t. So that gives us 1 t plus 1 and 1. Or sorry, 1 t plus 1 and 1, yeah, across the bottom. Now we have to subtract r2 by r1. That gives us 0, 1, 1 along the bottom. And now we just need to take r1 and subtract t r2 from it, which gives us 1, 0, negative t, and 0, 1, 1 across the bottom. So this gives us v1 equals negative t, and v2 equals 1. Or sorry, v1 prime equals negative t, and v2 prime equals 1. Integrating these, we get v1 equals negative t squared over 2, and v2 equals t. So that means our particular solution, which is v1y1 plus v2y2, is going to equal negative t squared over 2 e to the t plus t times t e to the t, which is just t squared e to the t. This simplifies to t squared e to the t divided by 2. So our y of t is in our homogeneous solution, c1 e to the t plus c2 t e to the t plus t squared over 2 e to the t.